trachea is the airway. You only got one of them. Yeah, look at the picture. It's not very long. You can feel your larynx, right, the laryngeal prominence. So right below that is trachea, and then it goes right down to the sternal angle, so I can feel the top of my manubrium. And it just goes right down to there. So it's only about like that, about 11 centimeters. Okay. Centimeters in length. Maybe something like 2 centimeters in diameter. So if we take our larynx model here, and kind of like that can accommodate, you know, maybe one finger. Okay, that's all we're talking about here for your airway. And what we see on the next slide is that on the back it has soft tissue, but in the front there's this hyaline cartilage which is stiff. You take a section right there, you can see that the trachea is anterior to the esophagus posteriorly. So that way when you swallow food, the bolus of food there's some give as it passes along the posterior surface of the trachea. Now what I want you to learn from this slide are the layers of the tracheal wall. There's a mucosa, a submucosa, and an adventitia. All right, so if we look at the histology pictures, like this one, this is a low mag 40X. And we see these big cut rings, the cartilage rings. That's the most significant thing that pops out at a low mag. But our layers are mucosa. From here to here is all submucosa. And then from here to here is all adventitia. Let's go medium magnification. We're going to go to a high mag so we can get a close look at the epithelium. So this is a 400X. Basically, this is a big mucous membrane. And the epithelium of the mucosa is ciliated, pseudostratified, columnar, epithelial tissue with, we'll squeeze it up here, goblet cells. Now remember, goblet cells are unicellular glands that secrete mucus. So it's all about the cilia and the mucus. Now, just below this epithelium is a loose connective tissue. It acts like a basement membrane. We call it the lamina propria. Lamina propria. I'll describe it as a loose CT, connective tissue. So the goblet cells secrete mucus, but also the layer underneath is primarily for mucus secretion. All of these cuboidal cells, those are seromucus glands. Okay. This is all submucosa right there. So that's the structure I want you to be able to identify in submucosa. Let's get the layers. It goes mucosa, submucosa. Be able to identify seromucus glands. Each one of those glands has a duct to the surface. Wherever you see a little divot in the epithelium, like right there, that's like where one of these has a duct going to it, so you can kind of spit the mucus on the top. On this slide, I like it because the seromucus gland, you can see it going all the way and emptying on the top there. So imagine a big layer of mucus on here, along with the cilia beating in a rhythmic fashion. there's a function called the Mucus Escalator. Let me cue up a YouTube video to show you what that is. I'm going to cue it right where I show the mucus escalator for real. There's no sound, but let me turn the lights off so you can kind of. You see the dark spots? And they're all moving in one direction? That's the mucus escalator. It traps debris, and with all the mucus and the cilia, they beat one way. So things only go up and out in the respiratory tract. That's what I want you to see. Mucus escalator. That was for real. That wasn't a computer simulation or anything like that. Okay, so back to this. So you can appreciate the hairy cilia and all this mucus performing that function. A smoker's cough is due to, well, the cigarette smoke killing the cilia. So you don't have the mucus escalator, so a smoker's cough is very frustrating from what I hear. It's not a very productive cough because you don't have that mucus escalator function. But if you're able to quit, epithelial tissue is highly regenerative and you'll get it back. All right, let's see here. There's the slide for the mucus escalator. Let me go back and teach Adventitia, this slide. All this is, there's other tissue types, but I would just have you identify this tracheal ring of the Adventitia. Adventitia. It's the outermost layer. Now the tracheal ring it's not a complete circle, it's C-shaped. So I say ring, but that's misleading. A ring is a complete circle. It's more or less C-shaped, and well, it's made out of a hyaline cartilage. Keeps the airway open. Hyaline cartilage. All right, so that's trachea. I'm going to move on.
Can you show where the hyaline ring is?
Yeah. So if we go back to this slide, it's more like a horseshoe, right?
Right.
We say it's C-shaped. It's not a complete ring. Okay. Soft tissue in the back. And so what you're doing is, when you look at the slides, it's like you're cutting down like that. You're cutting each ring like that, from top to bottom. So when you look at it like this is a ring, that's a ring, that's a ring. Just cutting down longitudinally down the tube. Okay. All right, but that's hyaline cartilage. Remember the name of the cell type? Chondrocytes in lacuna. Does that ring a bell? That's a cell type for the hyaline cartilage. Now it has that frosted pink appearance. But really, the collagen fibers are packed so tightly together, you can't make out the individual fibers. It just has that frosted appearance. All right, so let's move on. Well, I showed you the mucus escalator. Let's move on. Let's talk about when the airway divides and the airways go into the lung tissue. Call this the bronchial tree. Think of a tree, the trunk of a tree, and it branches out, and all these branches. And So in breathing, the trachea ends with the last cartilage ring, and it's called the carina. Maybe that'll be my last trachea note. It's the last tracheal ring where the airway divides for the first time. And it's going to divide into the right and left bronchi. We're going to outline all that. But just know that at the time air reaches this area, the trachea, air reaching the bronchi, it's already been warmed and cleansed of impurities. It's saturated with water vapor. And the bronchi are going to subdivide and subdivide. And there's actually 23 or 24 orders of branching. I say 23 here. Okay, let's get to this picture here. Here we see the branching. We see the trachea, we see the larynx above it, and we see the bronchi below it. So the bronchial tree it undergoes 23, 24 orders of division. Every time you divide, the airways get more numerous, but they get smaller. Undergo 23 to 24 divisions. We're going to increase, proliferate the airways. So if you keep track of the division number, it's really an upside down tree, right? As it branches. Division 0, before it divides, that's the trachea. You got one trachea, okay, and it divides at the carina. But what we already noted about it is everything I want you to know. It's got the C-shaped cartilage rings. That's the main structural feature. It divides at the carina, which I call the underpants. Left underpants. But anyways, that first division, one airway divides into two. You're going to have two primary bronchi. Primary because it's the first division, but the two airways, it's the right main bronchus and the left main bronchus. Each of those, you can see on the figure, the one on the right, the one on the left. Okay. It's the legs going through the underpants, right, so to speak. Well, each of these airways is delivering fresh air to the right and left lungs, respectively, right? Correct. Let's see. Each delivers air to right, left lungs respectively. And most people already know you have a right lung and a left lung. And, so you need the air to get there, so you have these main bronchi, the right and the left. That's just the first division. One airway becomes two. In the second division, two airways become five. The second division is going to give rise to 5 secondary bronchi. Each of these 5 airways is delivering fresh air to a lobe of a lung. You got 3 on the right, 2 on the left. So you can call them lobar bronchi for that reason. So 3 lobar bronchi, that goes to the right lung. You got 2 lobar bronchi, that go to the left lung. Now, these 5 areas have different names. Just call them all lobar bronchus. There's 1, 2 there. There's like 1, 2, 3 there. Okay, study the figure. There's 5 of them, and what I did was I kind of made big arrows. Those 2. If I got 2 arrows, which level is it? Yeah, this first division, the primary. So that's the carina, right? The underpants. And there's 1, 2, 3, 4, 5 lobar bronchi. Don't gotta individually name the 5, just call them all secondary bronchi or a lobar bronchus. You're gonna get it right. Each delivers air to a lobe of the lung. So now you know the right lung has 3 lobes and the left lung has 2 lobes. All right, now the third division, you go from 5 to like, sometimes it's 19, sometimes it's 20. Yesterday I read it was 18. Let's go with 18 today. I feel like 18. We're going 18. But something like that. It's the third division. So we call these, the tertiary bronchi. It's the third division. Tertiary means 3. You got 18. You got 10 that go to the right lung. You got 8 in the left lung. You can also refer to these 18 as segmental bronchi because they're delivering fresh air to a segment of a lobe. And the next slide, I got them color-coded here. So you can see how the airway is delivering to a segment of a lobe. We call them bronchopulmonary segments, so also known as segmental bronchi. Okay. The idea of a bronchopulmonary segment, I've heard it's useful for surgeons who have to maybe remove part of your lung, maybe do a tumor or something, but you use the anatomy of the airways to get the lung tissue, the airway, and you're also going to get the blood supply and everything else with it, which comes as a nice little package, okay, to get it all together. Okay, so no bronchopulmonary segment. Okay, that refers to this slide. You can track which airway is delivering to which part of which segment of the lobe. Now, there's 23, 24 divisions. I'm going like 0, 1, 2, 3, but just to be more expedient about it, after 3, then you go 4, 5, 6, 7, 8, 9, 10. From 3 to 10, the airways are getting more numerous and smaller. You start to call them all from like 4 on to 10 subsegmental bronchi. They still have cartilage as you continue to branch. Let me go to the slide. So from 3 to 10, subsegmental bronchi. But you're getting into the thousands as you branch out to the 10th time. Too many to count. Okay, we have 19, 18, that's a number we can wrap our heads around. When we get starting into the thousands, I just usually say a lot of airways, and they're getting smaller. And what's happening structurally is, if you look at the top of this, what they've done in this picture is they've taken the airway and they're pruning all the branch points. So it's easy to see, it's a straight shot down to here. And with each branch point, you can see the cartilage is starting to thin out. As long as there's cartilage, you still call it, number one, bronchus. Okay? And at level division 10, these bronchi, they still have cartilage, but it's less so. So you have decreasing amounts of cartilage up with that. Decreasing amounts of cartilage. But around 10 to 11, it changes from bronchi to bronchiole. By definition, the bronchiole, no cartilage. You start to see increasing amounts of smooth muscle. Increasing amounts of smooth muscle. So you got to get all the way down to the bronchiole level. Bronchiole is like arterial. The arterioles are just TITM, no TA. They're smooth muscle. And this is the level at which the sympathetic nervous systems could say, for example, bronchodilate, because you got the smooth muscle. So I'll put that as a side note, SYM, sympathetic nervous system. Okay, bronchodilate. Yeah. So on the slide, bronchioles, number 2, notice from here on out, there's no cartilage. Okay, that's what I want you to notice. There's a few orders of branching for the bronchioles. It's like 11 to 16. So let's start at the top again. Down to 16. It's all bronchial. Now 16, that's kind of like what we call the terminal bronchial. I think I mentioned this before. So we're getting to around like something like when you're at the bronchial level, you're at 11 to 16, you're getting at like 80,000-ish airways. Okay, a lot. And the terminal bronchioles mark the end of the conducting zone. The next 3 orders of division, 17, 18, 19, call them respiratory bronchioles. So again, for bronchioles, look for the smooth muscle and also look for increasing amounts of elastic fibers in terms of structural features. No cartilage, cartilage gone. Okay, so smooth muscle, fibers versus elastic fibers. The elastic is really important. They always describe the lung as a balloon. When you inflate the balloon, you got to let the air out. It's the elastic recoil of those fibers that help the lungs collapse to push air out of your lungs passively. So that's an important structural feature. So now we're getting down. Okay, so where we were, I said terminal bronchiole. On the figure is number 5, right there. And I know it's hard to see, but past number 5, past that point, you'll start to see little bulbs stick out. Those are the alveolar spaces for the gas exchange. So number 4 is the respiratory zone. That's where you can first have gas exchange right here. This is the first opportunity for gas exchange. Occurs right here. gas exchange begins to occur. Let's look at a close-up of the respiratory zone. I wanted to show you that. See the picture on the left? It's in the lab. It's on one of our models, and I think this picture from the atlas is good to study at home. But for the lab practical, I got that on the model so I can utilize that. I don't necessarily have to print out a picture of that, although I can do both, I guess. Here's a picture of the respiratory zone, the very bottom, the dead end. Remember, the respiratory system is a dead end, the alveolar spaces. We're not quite there yet. We got to get to like 23, 24. So let me point something out. See these these fibers going around? They look kind of like rubber bands to me. Those are the smooth muscle fibers. But you see the dark blackish fibers around the alveolar spaces and also running up and down the respiratory bronchioles? Those are the elastic fibers. So on pictures and models, look for the elastic fibers. I may ask you to identify them. The respiratory bronchioles are studded with these alveolar spaces. That's one thing you notice about it. Okay. But when you get past level 19, you go 20, 21, 22. Those are the alveolar ducts. Now the alveolar ducts, they lead directly into alveoli, the dead end, the individual tiny microscopic air sacs. And they do point to one alveolar duct on the picture there. So it's in the center, right? And it opens up into individual alveolar spaces. Okay. And so that's pretty much the last order of division. We'll just get to number 23 here. 23 is a single alveolus. I guess plural is alveoli. Let's remember, as I mentioned earlier, you got 600,000 of them. I mean, 600 million, sorry. So we went from one airway to 600 million tiny spaces for gas exchange. There's other structures labeled here. Number 7, they term acinus, which just refers to many clusters of grapes, right? Many clusters of alveoli. That's all I think of it. So if many clusters of grapes is the acinus, an alveolar sac, number 8, is just one cluster of grapes. One grape is just one alveolar space. Okay, so that's just the terms. So I should write that down. You are responsible for that. You got to know acinus, alveolar sac, alveolus. Acinus, many clusters of grapes, alveolar sac, one cluster of grapes, alveolus, one grape, one alveolar space. But that's it, that's the dead end. Once you get to the alveolar space, you've delivered fresh air, you've ventilated the lungs. And so then you have to think about it in conjunction with the pulmonary circulation so you can have the gas exchange. So let's add in the pulmonary circulation with this respiratory zone shown here. It's a nice picture. I think the anatomy you need to be familiar with is that know that this tissue needs regular systemic circulation just like anything else. So for example, note the bronchial artery. That's the artery that's just supplying oxygen-rich blood to this region. But let's focus on the pulmonary circulation. It's the job of the right heart to pump deoxygenated blood to the lungs to get oxygen. So if you follow this branch of pulmonary artery, notice how it follows the airway. It's following the airway. That's what I would note. branch of pulmonary artery. Now they color it blue, and that usually means, and it does here, deoxygenated blood. Remember that? Okay, so then follow the blue artery. Do you see how it kind of like leads the pulmonary capillaries, and it's kind of like a nice circular net around the round alveolar space? And then you get the gas exchange, and it goes from blue to red. And it's the job of the pulmonary venules to collect all that oxygenated blood. They're off the airway. They're on the side within the septum between lobules. Okay, so artery on the airway, pulmonary vein off the airway. And it's collecting and returning that oxygenated blood to the left heart. Branch of whole. Oxygenated. That's the circulation. Here's a model we have in the room. This isn't too clear about the artery on, vein off the airway. Well, here's one clue. Look at the thickness of the vessel wall, here and here. Which vessel wall is thicker, the blue or the red? Blue is, and usually arteries have a thicker vessel wall. So we're going pulmonary artery there. Okay, so pulmonary vein. Let's see here. Oh, look at this. Those reddish ones. What do you think? Smooth muscle or elastic fibers? Smooth muscle. If you look down here, these are yellow bands. That's how they model the elastic fibers. That's a bronchial artery, just supplying oxygenated blood to the region. Okay. Now, it's kind of hiding here. But if I point to a bronchial that has a little alveolar space on it, it's the respiratory bronchial. If it doesn't have the alveolar spaces on it, you can just call it a terminal bronchial. Okay. Just don't call it respiratory because it's got to have the alveolar spaces on it. And this is the model that has that picture. In case you're wondering where it came from, it's on this model. So let's talk about the respiratory membrane where the gas exchange occurs. And you have a nice figure on it. So to give you a review of the division that we did, we start with division 0 before the airway divides. And the diameter is given here. I mean, they get smaller and smaller, but what's more impressive is how numerous they are. You get to the 11th division, you're up to like 10,000. Here you're up to 80 million, 600, I mean, it's a lot. You get to the end, 600 million. That leads to a cross-sectional area of more than 1 million. Cross-sectional area in centimeters. That's probably enough to carpet this room, okay? Or half of this room. At one point I did the math, it's something like that. That's a lot of space that's tucked into your lungs. Okay, it's pretty remarkable. Now, an illustration of the alveolar spaces with the pulmonary capillaries is shown here. So the space is this circular space. And you see all the little pulmonary capillaries at the corners. Okay? That's where the gas exchange can occur. So what they do is they kind of like blow up an interaction between alveolar wall, where the fresh air is, and red blood cell in a pulmonary capillary. So this is the respiratory membrane. So, I'm going to draw this cell. This is It's a cell of the alveolar wall of the alveolar space. I would describe it as a simple squamous epithelial cell. This cell here. You have a little nucleus in there. So in defining the respiratory membrane, type 1 cell. This is the main cell of the alveolar wall. Okay. I mean, it's all of the cells you see here. It's most of them. Main cell of alveolar wall. Okay, well, there are other cell types, but let me talk about how it interacts with the pulmonary capillary. So this cell, this red cell, is the endothelial cell of a blood vessel, of a pulmonary capillary. Nucleus is down there. It's the endothelial cell of a capillary. They're fused together with connective tissue. They just call it fused basement membrane on the figure. I'll use, how about blue? Fusing it together. Put all that together, 1, 2, 3, is the respiratory membrane. It's number 1, type 1 cell. It's number 2, the endothelial cell from the blood vessel. And number 3, the thing that fuses them together. So that way, blood can exchange across that very thin membrane, okay? And O2 can be delivered to the blood, and CO2 can be dumped into the air, little airspace so you can breathe it off. CO2 goes the other way, and that's the gas exchange. Well, we call that external respiration, correct? Let me define the other cells that are shown here. This green cell that's more round is the type 2 cell. So let me draw a green cell here. More round. It's a type 2 surfactant cell. Surfactant secreting cell. It's the little green blob I drew there, type 2. Surfactants are very important. Surfactants, they break the surface tension of all the water vapor lining the alveolar spaces. If you can break that surface tension, it makes the lungs more compliant. They're easier to inflate with air. Break surface tension. That's kind of what you worry about in preemies, premature births. They're not quite making the surfactant yet, so they need help breathing when they're born. One of my friends, he's a respiratory therapist, and sometimes, like, you know, they get the APGAR score. He's kind of evaluating the baby. And if the baby's having trouble breathing, maybe the color's off. He goes, yeah, I'll just kind of hit it a couple times. It starts to, I don't know. I guess it takes a little time if it's a normal birth, but eventually the surfactants get going because this baby just started to breathe. All right, this is the second it was born, and you got to wait for those surfactants to kick in to make the lungs easier to inflate. So that's why you need to know the type 2 cells. You also need to know the macrophages, right there, colored purple, keep things sterile. So I'll list that as another cell type here. Macrophage. I put a line. It's not part of the respiratory membrane, but they are there for sterility. That's important. So I'm going to move on from this slide. Let's look at a picture of a model that shows this alveolar space and see if you can identify type 1, type 2. Now, the type 2 are more round. So they, by design, they kind of put this flat cell and this more round cell. So flat cell type 1, more round cell type 2. Okay. All these little star-shaped things, those are the resident macrophages. All right, that's all they show you there. So this is on the back of that model. Okay. Just so you know where it is in the lab. If you look at the histology of healthy lung tissue, this is what we see. This is deep in the lung tissue. This is bronchiole. And you see how it branches right there? And when it branches, it gives rise to bronchial / alveolar duct. The alveolar duct is like a hallway. And along the hallway, there's all these rooms. So I guess in my analogy, the rooms are the alveolar spaces, but the hallway is the alveolar duct. An alveolar sac is more like a round structure like this. And at the ends, it opens up into individual alveolar spaces. Okay. So be able to identify alveolar duct versus just alveolus, bronchial. Okay, that's about all I can ask you besides, well, let me do this. What if I said identify? What would you put? Alveolar sac. But what if I point it right to, say, here? Alveolus. What do you think this is? Yeah, alveolar duct. On the schedule, there's a cardiorespiratory quiz. It's on the schedule for Friday, but what I'm going to do is present some slides for the quiz, and the quiz will be on proctorial. First available on Monday. Here's bronchial. I wanted to show you a bronchial wall. Notice the epithelium and notice the smooth muscle. Okay. Okay, bronchial, smooth muscle. I want to describe that epithelium as a cuboidal ET with sparse cilia. So what I did was I put trachea and bronchial right next to each other so you can see the differences. It's not to scale, but just to give an idea what it looks like. The trachea is a ciliated, pseudostratified columnar ET with goblet cells, that whole thing, but it really thins out when you get down to the bronchial level. Okay. Well, let's go back to a gross anatomy view and just look at the lungs by themselves. The anatomy is pretty easy. When you remove them from the chest cavity, It's hard to tell, but the apex goes all the way up into your neck when you breathe in. You go all the way up to the root of your neck. So that's how far up they go. And they go all the way down to the diaphragm down here. Just be able to identify the lobes and if it's left or right lung. This is the surface that's stuck to the chest wall. So they call that the costal surface, because costal means rib. And I even think they tried to illustrate little black deposits. That's typically what I see when I open a cadaver. It's just a matter of how much black deposits I'll see. It doesn't necessarily mean the person was a smoker, although they certainly could have been. But if it's all the dirty air we breathe, just living in the city. Okay, so we got right lung, left lung, well, the right lung has 3 lobes. There's the superior, middle, and inferior lobes. Superior, middle, inferior lobes, separated by 2 fissures. Okay, so let's kind of note that. You can tell it's the right lung if it's got 3 lobes. Superior lobe, and the superior lobe is separated by the lobe below it, by the horizontal fissure. This fissure right there. Horizontal fissure. Runs more or less horizontally. Then you got middle lobe. Then, middle lobe, I see this oblique running fissure. Then you have inferior lobe. So that's not too hard, just the lobes of the lung on the right. But on the left, it's just superior and oblique. So superior lobe, oblique fissure, then inferior lobe. Superior lobe, oblique fissure, inferior lobe. So be able to tell the right lung from the left lung, be able to identify the lobes and fissures, and if you turn the lungs inward, you can see the hilum of the lung. This is where things enter and exit. You even see the cardiac impression there, the impression of the heart. So this would be aorta, the impression of the aorta. So let's look at the hilum here. You can see, well, okay, let me just say this. Look for the hilum of the lung. That's spelled H-I-L-U-M. Hilum is where things enter and exit the organ. Be able to identify the airway, like for example, that's the lobar bronchi right there. These are also lobar bronchi right here. I may have you identify the pulmonary artery or the pulmonary vein. Be able to identify those things within the hilum of the lung. This is a good place to stop.